Hello everyone, welcome to MES e-learning channel. In this video, we will be trying to solve a numerical on Routh stability's criterion. Here we will see the case 1. There are a total of 3 cases. So, let us see them one by one. In this video, we will be discussing case 1, that is no zeros. Let us try to solve a numerical and try to understand the topic better. So, the first thing while solving the numerical is that we will have to build the Routh's array. Okay. So, to build the Routh's array, we have to see the term that has the highest power. So, here we have s raised to 4. So, we will write s raised to 4, then s raised to 3, s raised to 2, s raised to 1 and s raised to 0, okay, because s raised to 0 or anything raised to 0 is 1. So, we can write s raised to 0. Okay. So, here we will be able to fill the first 2 rows in the Routh's array by the characteristic equation that has been given to us. This is called as the characteristic equation. Okay. So, in the first row, okay, we will be filling all the numbers which have s with an even power, okay, and here in this particular row we will be filling all the s with odd. Now, why even and odd? It is not like we will be writing even first and then odd. We will be observing this particular term over here, right? From where, why did we start with s raised to 4? Because here in the characteristic equation, the highest power of s is 4, right? So, 4 is an even number, hence we will be filling all the numbers which are multiplied with s that has an even power, and here we will be writing odd. I hope that is clear. So, here we will be writing 1, since here s raised to 4 has no number with it. So, it indicates the number is 1. Then this is the positive or the even power. So, 18 and this is s raised to 0 even again. So, 5, okay, or else you can write like this also, like 1, 8, 18, then 16, 5 and then here there is nothing. So, you can keep it blank or you can also write 0. Now, you can see 8 is with s raised to 3 which is an odd power, and 16 s raised to 1, 1 is an odd power. Okay. So, now we have to fill the array. So, to fill the array we will have to do some calculations. So, for s raised to 2 row, that is this, we will be looking at the preceding 2 rows. Okay. So, the preceding 2 rows are these 2, right. So, the immediate 2 values that are above are 1 and 8 that we will write, okay, and we will be using the next 2 values, that is 18 and 16, to find the value that is over here. Okay. So, I will write it over here. Then we will be doing a cross multiplication. Okay. We will always be starting with this number that is just above here. Okay. So, this can be solved like this. We will write 8 into 18 minus 16 into 1. Okay. We will be writing minus here, 16 into 1 divided by 8. So, after you solve this, the final answer that you will get is 16. This 16 can be written over here. To find the value for this particular position, again we will be using these 2 values, that is 1 and 8, okay, 1 and 8, okay. Please keep in mind you will be using 1 and 8, and then since you have already used these 2 numbers, right, for this position you will be using these 2 numbers, that is 5 and 0. So, we have not used 18 and 16, we will be using this, okay, 1 and 18, it will remain constant, and instead of 18 and 16, since we have already used it, we will be using 5 and 0, we will be moving ahead and we will be using 5 and 0 for this position. Again we cross multiply, always remember we start with this number, okay. So, start from here. So, we will have 8 into 5 minus 0 into 1 upon this number, that is 8. Okay. So, after you solve this, you will get the value as 5. We can write this 5 over here. Okay. I hope you have understood. Now, let us move ahead and try to solve for S1. For S1, you can pause for a minute and try to think which 4 values we will be using. Please remember, we will be using the preceding 2 rows that are just above S1. Okay. So, we will be using these 2 numbers now. Preceding just above S1 is this row and this row. So, we will have 8, 16, right, and we will be using 16 and 5. We will be cross multiplying starting with this number. Okay. So, we have 16 into 16 minus 8 into 5. 8 into 5 divided by 16. Okay. So, once you solve this, you will have answer as 13.5. Let us write 13.5 over here. Now, to find the value for this position, we will again be using these 2 numbers, that is 8 and 16. This will remain common. Please do not make a mistake of using these 2 numbers. Okay. We will always be using these 2 numbers 8, 16, and then since these 2 values are already used, we will move ahead and come here. But you can observe we have a 0 here and there is no value here, which indicates there is a 0 here. So, multiplying these 2 numbers 8 and 16 with 0 will ultimately give us a 0. So, there is no point solving it. So, let us keep that place blank, or you can simply fill in with a 0. Now, let us solve for S0. S raised to 0, we will be using the preceding 2 rows now, that is 16 and 13.5, and we have 5 and 0, okay, which is just beside it. So, 5 and 0, let us cross multiply, always starting with this number. So, we have 13.5 into 5 minus 0 into 16 upon 13.5. Okay. So, you will get 5 as the answer. Okay. So, let us write 5 over here. So, now we have totally built the Routh's array. Now, after completely writing the Routh's array, the next step is to observe the first column of the Routh's array and to see if there is any sign change. Okay, I will just write it clearly. There is 1, there is 8, there is 16, then there is 13.5, and then there is 5. So, these are the 5 values that we have in the first column. I have simply written it again so that you can see it clearly. Now, we can see that all these numbers are positive. So, there is no sign change happening. This is positive, positive to positive, positive to positive, positive to positive, and positive to positive. So, all the numbers are having the same sign, that is they are positive. So, since there is no sign change, okay, since there is no sign change where in the first column of Routh's array, this indicates that all the roots, I told you what are roots? Roots are poles and zeros. All the roots are lying on the negative half of the S plane. Okay. So, since all the roots are lying on the negative half of the S plane, this indicates that the system is stable. Okay. So, after completing the Routh's array, you have to write this conclusion and you have to write if the system is stable or unstable. How did we identify if this particular system is stable? We saw the first column of the Routh's array that we built, we saw that there is no sign change. Since there is no sign change in the first column of Routh's array, we come to know that all the roots are lying on the negative side or the negative half of the S plane. And so we come to the conclusion that the system is stable. Okay. So here we saw that there are no zeros present. Okay. So this is the case 1. There are 2 more cases that we will be discussing in the upcoming videos. Thanks for watching.